All right, let's attempt this big problem here. We have a roller support over here on the right, so that's just going to be some kind of force like this. We have a pin support on the left, so I need to put in 2 forces. That's the first thing we always do. Next thing we want to do is maybe find some angles. There was no angles given in this thing, so this A right here I know has to be 45 degrees because it would be 3. It'd be 3 over and then 3 up. So those are equal sides, so I know that that's a 45 degree. That's the same with over here, so this is 45 degree. This thing is all symmetrical. This one here would be 2 over and 3 up. So this is 3 and this is 2. So the angle here, the tangent of this angle would be the opposite, 3, over the adjacent 2. So I'll do that in the calculator real quick. 3 divided by 2. Inverse tangent, I get a 56.3. So this one is 56.3. And then this one is 56.3 also. Okay, I'll erase some of these things in here. All right. Okay, that's good. All right, so the first things, remember, we do is we do ups and downs, lefts and rights, and torques. So there is only one possible left or right force right down here on the side. And because there's only one and it needs to be balanced, we know that we don't have to worry about it. This actually has to be 0. There's no force going that way. So I'm going to go ahead and erase that whole thing. Don't actually need it. Okay. Now we have ups and downs. So I'll just make a little chart, ups, downs. We have we have down is 1,000. We have 250, and we have a 500. That's a total of 1,750. Down, ups we have, we'll call this F1, and we call this F2. We know that F1 is up, they're going to be an up, and F2 is going to be an up. There's going to have to counteract those 3 things. So we want to figure out maybe what like F2 is and then be able to figure out what F1 is. So what we're going to do first is we're going to do torques, clockwise, counterclockwise torques. And we're going to pick one of these sides as our reference point. I'll go ahead and choose this one. So right now we don't have to worry about what F1 is. We can figure out the torque. So if I go all the way over to here, I have a down one right here. That's going to be clockwise. It's going to go around this way. 1,000 times 3. That's a clockwise. And then if I come all the way over here to this 250, I have a 250 times 5. And then if I come all the way over to here, I have 500 times 7. 500 times 7. Those are all clockwise torques. Now if I come all the way over here to F2, okay, this has to be an up force to balance out all those other torques. So it's a counterclockwise torque. So F2 times 5, 6, 7, 10 times 10. Okay, so I can add these all up. I'd have 3,000 plus, that'd be 1,250 plus 3,500. Gives me a total of 7,750. Divide that by 10, and my F2 over here should be 775. And now I know that this F2 right here is 775. So I can take these downs, 1,700 minus 775. And I know that this over here is 925. Okay, 925. And that's an up force also. And we might want to think, does this make sense? That this one over here on the left is bigger than the one over here on the right. And yes, it does, because here's 1,000 pounds right there. That's bigger. It's kind of more towards this side. So we'd expect this left one to be a lot bigger. Okay, I think we have all of our forces on there now, and we can start doing is, are we still going? Okay. I don't know what I did there. Sorry about that. That was a complete mess up. I got out of the program, it looks like, a little bit. Okay, we'll just keep going. It's glitchy. I'm learning this stuff, you know. I'm in quarantine. Okay. All right, so we're going to start doing some internal forces here. So we need to pick a joint and start kind of figuring out stuff. So I'm going to go over to this one here, and I have a 775 up. And I got something coming this way. I don't know if it's going out or in. And I have something coming on this. Those are my only 3 possibilities there. So I know right away that this one here has to be, let me erase this arrow here. This one here has to be a over to the right and a down. I know that has to be because I have an up here, and this has to be providing the down. And because that's down, I know that that's 775. Now this is 45-degree angle, right? So this is a 45-degree angle, and if that's 775, that means this is 775. And so, and I know that this force is going this way now. It's compressing this joint, so it's going to be a negative answer. And I can come up here and I can put in the arrow going the other way too in this member. And this is an easy calculation. It's the Pythagorean Theorem. So 775 squared plus 775 squared square root. And I get a, this would be a negative. It would be a negative 1096 for E, whatever that thing is. EC, I guess. EC. Should be negative 1096. Okay, what else do we know? Well, if this was going 775 this way, it has to be going 775 this way. This left has to balance out that right. Again, this down balanced out this up. So if this is going this way, then I know I can come over here and do this. And these are tensions because they're pulling away from the joints. That's a plus, and I know it's 775. So I actually have another answer, BC. BC should be a plus 775. All right, let's go back over here, clear over here to the other side. Kind of do the same thing that we can do over here. So this was 925 going up. This thing I know then has to go over and down. And this has to be 925. And this has to be 925. And since this is going the left 925, then this is going the right 925. And that means it's coming in this way. And this is a tension, and so this is a tension of a plus 925. So we got another one done. AB is a plus 925, I think. I hope that's right. I think I tried to write down the answer wrong earlier, so we'll see. Okay, so then I have a 925 squared plus 925 squared equals square root. And I get a, let's see, for the AD, I think I have something wrong. I need to go back. Was this 925 or is this 975? I have a bad feeling it's 975. Let's see. I erased all my torques, so that's great. 1,000 times 3. Plus 250 times 5 plus 500 times 5, 6, 7 equals, divide by 10 was 775, and then all my downs. Okay, there's where I went wrong, I bet. All my downs are 1750. Right? All the downs are 1750. 1750, yeah, minus 775 is 975. Okay, yep, I had that wrong. I thought it looked like a 2, but it didn't. 975. So this is 975. Sorry about all that again. I'm winging this one pretty badly. So this right here, AB is 975, a plus 975. And then if I do the 975 squared, this part right here, I get a negative because this is going to be going into this, going to be a compression like this. I get a negative 1379. You can check the math there. Okay, so we got a lot of them done now. Let's go up. Let's go up to here. So I know that this going in like this is a 975 up and a 975 over. Okay, I know that for a fact. I know I have 1,000 down right here. Let's see. What else do we have here? Okay, maybe I want to come, let's see. I can come over here too, and I can make sure that I got this going up 775, and this would be going over 775. Okay. All right. So let's stay over here on this side for a quick second. This is 500 down, and this is 775 up. Okay. So what do I still need? What do I still need? I have 775 up. I have 500 down. I need another 275 down, right, to balance these out, right? Another 275 down. 275 plus 500 would be 775 up. So that's how I know which way this thing is going. This thing has to be going down like this because it's going to be going over and down like this. And I know that this down here has to be 275. Okay, it has to be 275. So that'll balance all my ups and downs out. Okay. All right. What is this part here? Okay, so I'm going to need an angle in here. I actually know if this angle is 56.3, this angle is 56.3 also. So I can do tangent of 56.3. Tangent of 56.3 would equal the opposite, 275. So the opposite of this angle here would be this side over this side, x. Okay? So x would equal 275 over the tangent of 56.3. So I'll do that in the calculator. I hope you're following this, and this is a good problem. Divided by 56.3 tangent equals, it's 183. So this in here is 183. Okay, and now I can do Pythagorean theorem on both these things. So 275 squared plus 183 squared equals square root. I get a 330 basically. Let's see, that's BE. So this would be coming out to be a tension. So this would be like a plus 330. A plus 330. Now if we come back up here to this point, E. So let's think about this. Now we have 775 up on this part, was the up component of this. We have a 500 down. We have a 275 down, so this plus this equaled that. So my ups and downs are balanced. Now what about my lefts and rights? I have a 775 to the left. This component here gave me a 183 to the left, okay, which means what? I can add those together and I can figure out what this thing is, right? Because this thing has to be whatever these two are together. So 775 plus 183 equals a 958. And that's going to be coming in like that. That's a compression, right? So that's going to be like a negative 958 or negative 960. It's close enough. I am giving a little leeway in the answers on the ELAB, so you can be, I don't know, 5 off or something, and they'll still accept your answer. So hope you appreciate that. Okay, so that means this coming in here is 960. So what else do we have here? We know that we have an up of 975 and a down of 1,000. Okay, so that means we need some more up. How much more up? So that means this thing here, right here, that this has to be an up, right, of how much? Well, it'd have to be 25, right? 25 plus 975 is 1,000. And this has to be then going over like this. So this is going to go in like this. This is a compression. And how much is this thing coming over here? Well, I got 960 going over. I have 975 going over this way, so that means I need another, let's see, 15 going over that way, right? And I can do Pythagorean Theorem. 15 squared plus 25 squared equals square root, and I get like 29, like 30. So, right, and it's a compression. This is a compression. So this one here is like a negative 30. Now, you know, obviously you can just put the answers in and get them all right if I did it right. But, you know, you really need to go through this problem. This is a really good one to go through. It'll probably be one like this on the Jedi trial. So if you don't know how to do these, you're going to miss some of these on the Jedi trial. So you need to step through this, pause the video, and try to see if you can get all the way through all those answers. I think we got every single member, right? 1, 2, 3, 4, 5, 6, 7. We got all the members figured out. So sorry that took so long.